Hi, everyone. Thanks so much for joining me here today. Thanks for that awesome intro, too. That was great. All right, so I am Juliana Congote, or Jules. I work on the API platform, GraphQL platform team at Netflix. And I've spent the last few months trying to think of how we can come up with a good, foolproof mocking solution. And I can't tell you that I'll give you all the right answers today, but I can share a little bit of our journey and the different things that we've explored and our pros and our cons. So, fake it till you build it was born from a colleague of mine. I cannot take the credit for the awesome title, to be honest. Tejas was the one who helped me make it a little more clever. I was just going to say navigating GraphQL mocking solutions. So, let's get started. So first, I had to rename this slide because I realized that naming this schema first design is a bit controversial because people start saying code first, SDL first, and that's not what I mean when I say schema-centric design. Schema-centric design just means laying out the contract between the front end and the back end. So really focusing in on what that contract should look like, how it should be structured, and how it can be valuable to the client needs that are actually going to be consuming that contract. So nothing about SDL or code first, no controversies yet. So there was a big happy world where all designers and all the developers are around the SDL because we all get along great, right? There's no issues, there's no tension. Building a schema is so easy, and making it usable by all of our clients is really easy. It's just a happy world where we're all living in this federated ecosystem without any issues. So it's an easy premise, really. Here you can see we've got our TV UI, we've got Android or iOS, we've got a really old, really old, the top one is web, the bottom one is TV, really old TV, which I don't think would actually be able to power Netflix, but maybe if you hack it. It's actually a good idea. All right, so Collab between the front end and the back end is pretty simple. You send a query, hit your gateway, hit the underlying DGSs or subgraphs, get back a response, right? We're all happy, everything is easy, that contract looks great, the clients can use it, but in practice, I would argue that it looks something like this. Backend team goes to the client, here's the schema, here's the contract, here's the API, use it, you got something to say? And then the client, which sometimes, as we saw in our last image, it's not just one client. It's several different clients that you need to work with and collaborate with on different teams, different orgs, across different boundaries within our org. And then the client will be like, yes, we do have some thoughts about this. The client who's actually consuming it should be happy with the product they're consuming. Our APIs should be viewed as these beautiful products. Our contracts should be viewed as these beautiful products that they can use, because why are we building stuff if our own clients are unable to use it? And then, after having built the thing, having built the resolvers, the backend team will be like, all right, tell me what's wrong with it, a little bit annoyed. And so, it's like, why didn't you realize this sooner? After having gone in and built everything, you could have said something. And then what ends up happening? Well, it's easier to just add a new type to your schema. Maybe add a little underscore something to build it out for your next client. And we end up with this messy schema that isn't usable by so many clients. So I sense a little bit of tension here. There is, yeah, it's a little uncomfortable. And it shouldn't be, right? Building together should be something that's easy, should be something that is fun to work together. So let's go through the steps. We've got prototyping matters. Why? First, we collaborate on designing a schema. So that involves people using that schema and the people building the APIs that power that schema. We collaborate on designing that, and then we should be able to provide a useful prototype that says, here you go, here is what we agreed upon, test it out, let me know if this is actually working for your use case. Because again, schemas aren't just meant to be something pretty that we see on a UI and we can all look at and it's nicely documented. That's a symptom of an awesome system, which is a schema-driven system, but it's meant to be used by our clients. And then, only then, do we go into actually building this thing out. We're going to be talking about the second step, prototyping, because in order for you to actually have something to build something that's actually usable, we need to make sure that we have really nice prototypes. And that's when we get into mocking. So why does mocking matter? Well, it matters because we want to be able to have quick iterations. We want to be able to have a back and forth communication between our clients and our server teams and be able to roll out those changes incrementally without having that whole uncomfortable scenario that I laid out for you earlier. And we want to be able to test that without the backend fully integrated, we want to be able to test out these things so that the clients can start using it and not be apprehensive to say, hey, can we change this? Can we try this out? Can I make this schema update proposal or sup that should look like something that's more usable by us? And we want to make sure that when we do have that client-server integration, when all your clients go in and consume your schema, that it's something that they can actually use. Also provides predictable responses, right? So all of this allows for several clients to be able to use it, and it stabilizes our tests. They can go in and plug this into their end-to-end test. And when we do agree and build, we all know what we were signing up for. Because when you sign a contract, you should be able to know exactly what you're getting for your money. So let's get all our ducks in a row. My team and I found that when you say mocking, everybody gets excited. Everybody's like, oh yeah, we need mocking. And then that means a lot of different things. So I split it up into two different camps. This really could probably be several others. But one is business logic mocking. So that's just validating that the UI is behaving as you intended. So when I do this, the UI is actually behaving as I intended according to the data I am getting back. That can cross several service boundaries and not just necessarily your schema and your specific subgraphs. So that is not what we're talking about today. We're narrowing in on schema mocking or API data mocking. So this is where we type specific fields within your schema to JSON objects that represent potential responses. So this is useful for integration testing and rapid prototyping, as we just went over. So now that we all agree that we're in the second camp, and that's what we're talking about, let's fake it till we build it. All right, so sometimes you just have to figure out what it is that you need, and it's not always apparent. I can share all of the tips and tricks that we've learned, but depending on where you are at in your org, depending on where your schema is at, depending on how federated your graph truly is, how many teams are working on it, not necessarily every org has 400 plus subgraphs all working together. So today I really want you to keep that in mind as I walk through some of the things that we've explored, because this is very relative to where you are at. I cannot promise you a solution that'll fit each and every one of your use cases. So let's talk a little bit about the current state of GraphQL mocking. That's my dog, Mona. She's great, but she hates Mondays. She hates Mondays. That's her Monday face. Like, you can't cuddle with me, you can't walk me, you can't play with me. You're on the computer all day. You have to leave me. And that, to me, is what the first type of GraphQL mocking represents. It's a system where, the backend, like we talked about, goes in and gives you mock resolvers for whatever schema update proposal you're making. And this involves a lot of back and forth, because every time somebody says, can we try this out, requires a whole backend implementation. You have multiple environments with different schemas and different resolver logic for each, because, like we said, usually you'll have multiple clients. And then you have these long-lived feature branches for the clients, or feature flags kind of hiding all this logic, where they can't merge things in until you actually have this in production. So this one is a bit of a headache. Next one. This, if you recognize what this looks like, my colleagues Steven and Marc-Andre talked about schema update proposals 2 years ago at Summit. And we have a mocking solution that gives a bunch of random data, right? So this is not completely useless. It is nice to have if all you care about is the shape of your data. If all you care about is making sure that you're building that you can query that schema. And all you care about is the model, right? You don't care about what you're getting back. You just care about the model. So you can see that country code makes no sense. That phone code prefix makes no sense. But this has its pitfalls, which is that you can't add any constraints to it. There's no ability to specify the mock data that you want back. You can't control generic things like your links of your lists, how your phone number should look like. So it really limits the granularity of the mocking that you're giving back. But again, if all you care about is the schema itself and having valid queries that your UI can test against, and you can give them a graphical or a link that they can embed and test with, this could work. It's worked for us. Then there's this proxy type of thing, where essentially you have this mocking endpoint that splits the query up front so that the gateway can handle the existing parts, and then some mocks handle all the new stuff. So this is useful in getting that high fidelity that we're looking for. If you want more high fidelity mocks that resemble what actually would come back, because you're actually getting real data for where it exists in your graph, and you're getting mocks for what doesn't exist. The issue with this is that once a field is mocked, all of its children in that tree get mocked as well. So you cannot revert to real existing data for nested fields that do exist in your graph. So when we were exploring this option, I thought, this doesn't sit right with me because we have a deeply nested schema in many instances. And it's very complex to actually solve for that existing data if everything below the parent is getting mocked. And then splitting the query and combining those results can become really complex and error-prone for federated use cases. So although I would argue that of the ones that we've gone over, this one is probably the best, it does have its pitfalls if you are federating deeply, if you have a lot of nested types. I can stay here on stage all day talking about all the different mocking solutions out there. There's Apollo server mocking. There's tools that intercept at the network level. There's IDEs that offer built-in mocking capabilities. There's some GraphQL playgrounds that offer mocking. There's a lot of ways to fake it till you make it or fake it till you build it, essentially. But let's talk through why this is such a hard thing to cover. Because if there's so many different solutions out there, it probably means we don't have the right answer just yet. So this is going to be harder than I thought. This is a realization I had about 8 months ago when I was like, I'm going to go in and provide an awesome mocking solution. It's hard. It's a really hard problem to solve for. Why? Because we need to balance realism and practicality. So do we want real data? Do we want high fidelity data? Or do we want it to be practical and easy? Because just providing a bunch of random data is quite easy to do. Then handling federated schemas is really complex, like I said, because different service contributes to different parts of your overall schema. So properly stitching all this together can be really complex and error-prone. And customizing that, allowing for high-fidelity mocks that are customizable so that the UI that's integrating with it can say, I want this data to come back, or I want it to be completely static, snapshot data, so that I can reliably use this in my tests. And it has to be straightforward, it has to be intuitive, it has to be something that doesn't have a steep learning curve so that people actually want to adopt it and embed it into their everyday workflow. And we also need to be able to cover a wide range of data types and models. So the bigger your graph gets, the bigger your schema gets, there's a lot of different edge cases that you need to be able to cover. So I'm going to share some keys, some things that I've found and kept in mind in our mocking journey. So we want to make sure that the data itself that's coming back is useful. How do we do this? We can split real and fake mocks. We can give more realistic data. There's several ways to achieve high fidelity, some more complex than others. Usually, how complex it is correlated to how useful it is. So we also want to make sure that the mocks are easily customizable, that clients can go in and say, as we said, configure what they want, have lists of the size that they want, have a phone number actually look like a phone number. We also want to have it has to be user-friendly and intuitive. It shouldn't be, as we said, our contract is owned by everybody. Our schema contract is owned by everybody, so everybody should be able to draft us up a schema update proposal. Everybody should be able, whether you're a client or you're a backend, you should feel comfortable working with your schema. And in order for the testing of this feature to be valuable, we need to provide isolated testing federated environments. So a place where they can use your existing query planner without having to reinvent the wheel and actually test out what's going to come back from that schema update proposal. And as I said before, data, schemas tend to get more complex as it grows. So it needs to be scalable and forward-thinking so that we don't adopt one solution today and then 6 months down the line say, well, this is great, but it's not customizable. Our data is getting more complex. Our model is getting more complex, and I can't use this. So let me give you a few lessons that I've learned. Change is hard. Developers, as a developer myself, we like our workflows. We like to do things as we are used to doing them. We want to build something that is intuitive, that goes into developers' work streams, that the developer experience can be useful to them by not diverging too much from what they're currently doing, right? Because going in, having this async communication, talking through the schema, it can be a tedious task to do. And usually, we just want to go in and build the thing, right? We just want to go in and provide all the data, provide all the resolvers under the hood, and just get it out into production. And the solution should provide out-of-the-box advantages. So you can just go in, dream up a schema that you want to see, and have out-of-the-box mocks. You should be able to spin this up really quickly. Because if there's too much configuration, if it is too much of a hassle to set it up, we are lazy and we won't do it. What this means is that in order to provide a seamless, easy, intuitive user experience for people consuming our mocking solution, we usually, those who are building the mocking solution, have to take on a lot of the complexity. Why? Because generating mock schema, registering it somewhere, wiring up resolvers, all of that can be inherently complex. So that's a trade-off that we sometimes need to make, and it's a trade-off that I chose to make in our own solution. And we don't want to reinvent the wheel, and by wheel I mean query planner. If our solution, in order to scale, involves you having to essentially create a new query planner to figure out how to mock federated data, it's probably not it. Because what's going to happen the day that schema actually goes out into production and you query it, and your production query planner provides data that looks completely different than what you were testing. That's not going to be a good incentive for people to keep making schema update proposals. So I think together we'd make a pretty good team. Working together to get the right API shouldn't be painful, but it is. And we just have to figure out what the right tools are. So I'm going to provide a really high-level overview of a solution that some of my team members and I crafted and are working on. Again, this solution is not at its ideal state yet, and I'm going to do my best to try to portray all the ideas here. But this is really intended to get the conversation going around what useful mocks and a useful mocking solution looks like. So what we have is mock schema changes in the context of our federated environment, leveraging the DGS framework and existing infra. So essentially what we do is, and I'll go back to this, don't worry. If you've got this schema, pretty simple schema, I really spent a lot of time thinking up my field names, as you can see. So that's what my schema looks like. And I just want to go in and to that federated type, add another field that has requires. What we do is all of this is located in one central place. So whether you're the client or you're the server, you have access to all the schemas of both of, we have two supergraphs or two edges. You can access either of them. And you don't have to know or talk to the teams who own either of any of the subgraphs to actually use the solution. So when you want to add another field, You just go in and make the change. And in the backend, we'll extract the new functionality and plug it into a new subgraph, mock subgraph. The mock subgraph, which again is just, we call it DGS. The DGS framework is something that we built in-house. It's open sourced if you'd like to check it out. And it's our paved path solution for building Java DGS's subgraphs at Netflix. So this is what that mock DGS schema will look like. As you can see, I'm saying we don't own product. It's somewhere in the supergraph that product will lie. We're only going to mock out another field because that's the only thing that was added. And so once that is all set, what we do is we provide a federated gateway instance. You get a graphical, a URL, that you can test out this mocking, and it's all powered through existing infra. This isn't a new tool that we built. Again, my colleague Marc-Andre had a talk about all this infra and the DevX tooling that we have 2 years ago. I think it's available somewhere if you're interested in actually knowing the intricacies of this. But we're just reusing a lot of existing concepts that are familiar to our engineers at Netflix. And as I said, we're leveraging the DGS framework, so everybody's very comfortable with it. And out of the box, without having done anything besides what I showed you, adding another field to the schema, you get a lot of advantages because you get all the mock resolvers automatically are going to be fulfilled. So you can do an entities query, and you'll see that you just get a bunch of mocks. This is just a DGS. So it's not any foreign concept. If you want to go in and update those resolvers, make them more high fidelity, you can do that. And our engineers are comfortable doing that because it's just a DGS framework resolver that you can go in and customize all in one place. There's not a bunch of different repositories you have to go to leverage this. So this has a few pros and a few cons. Mainly, it's very customizable. In the future, we envision this, if it's adopted and if our engineers are on board with using it, we can see a future where this is embedded into a UI. The clients can go in and say, I want my JSON to look like this, my response to look like this. It'll craft your schema for you. It also does not diverge from our engineers' workflows. It's something that they're very comfortable with and very familiar with. And we're not diverging from our query planner whatsoever, because what a graph lab is just, which is our isolated federated environment, that URL, it's just a gateway instance that has our compose schema, and as part of that compose schema, that mock DGS schema that we extracted for you. So this is very powerful, and it can be more powerful. Again, we're not reinventing the wheel. We're leveraging federation. We're leveraging our existing query planner, and it does not diverge whatsoever from what we would have to do in like a proxy-like state, where you end up for nested fields, for nested types, you end up having to mock all of everything under it. Again, we're just extracting it and plugging it into a mock DGS. So I have a question for you all today, and it's, what does your GraphQL community need in order to facilitate collaboration? Because mocking is a little bit of a buzzword, right? Mocking, we need mocks. We need to have valuable mocks out there. We want to be able to build a very robust schema and mock things out. But why? What do your engineers need? Because, like I said, we started off with a very plain mocking solution that just gave back completely random data. And that worked for some time. But our orgs evolve, our engineers' knowledge evolve. Increasingly, engineers become more familiar with GraphQL, and they want to be able to handle more complex use cases. So depending on where you are at your GraphQL journey, that will dictate the mocking solution that will be most valuable to your engineers. Because just like we ask the backend, the server, to build a contract and an API that's going to be useful to their clients, as platform teams, we should be building tools that are useful to our engineers. And that's why this talk is called Fake It Till You Build It. Because when I was appointed the mocking czar, I was like, how am I going to do this? How am I going to figure out what all of our engineers, 1,000+ engineers working on GraphQL, need? And I started meeting with all these different teams, trying to figure out what they needed. And they all had different ideas, and they were all talking about different mocking solutions, and they were all talking about completely different use cases. So it's not as simple as just, here are some mocks for your schema. It really involves getting to know your customer base, your developers, and how we can make it so that when clients and server teams communicate with one another, this is the vibe we get. We're excited. We're ready. I want to talk to all of my different clients. I want to be able to work with all of them. I want to be able to have their input and not be annoyed at them saying, let's try this out. Let's test this out. Let's make some changes. So in order to get there, again, we need customizable mocks, intuitive mocks. The solution needs to be user-friendly, shouldn't have a steep learning curve, but it should allow for further customizations. It should be scalable, just like our data models should be scalable. And so, in the end, our end goal is this: facilitate that collaboration. So, if you have an answer to that, please let me know. I'll be around. I would love to hear what your needs are. And I think that we can really build a mocking solution that encapsulates a lot of different concepts if we all just work together. That big happy world that I showed at the beginning, it's possible. Tech is easy, people are hard. So we really need to figure out what our people need, both our clients, our servers, and the engineers building all of these products. So remember, if there's anything you take away from this, sometimes you just gotta start building things and fake it till you build it. Just start building it, just start talking to people in your org about what they need. And I hope that through all of this journey that we've gone through, you can have some takeaways and figure out where it is that you are and what is most useful to you. So, thank you very much. I'm Jules at Netflix, and I hope to see all of you around.